Good day, everyone. My name is Daniel Gold. Now, on today's video lesson, we're having questions on mole concept, calculations on mole concept. Question 1 says that find the volume of O2, which is oxygen gas, that will be formed when 2.45 gram of potassium triiosochlorate 5 were decomposed by heat. Potassium is 39, chlorine is 35.5, oxygen is 16, GMV, which is given molar volume, is 22.4 dm cube at STP. If it's at RTP, it will be 24.0 dm cube. And the equation for number 1 is given on the board. So let's quickly deal with number 1 question. We'll now move to number 2 question. So we are given potassium triiosochlorate decomposed by it to form potassium chloride and oxygen gas. So is it balanced? You have 2 potassium here, you have 1 potassium here, so I have 2 here. We have 2 potassium here, we have 2 potassium here. We have 2 chlorine, we have 2 chlorine. We have 6 oxygen, 2 times 3 is 6. And here also we have 6 oxygen. So the next thing is to find out the 2 relating substances. Now, the question says that find the volume of O2. So O2 here, meaning oxygen gas, is the unknown, because finding the 2 relating substances, the first one must be the unknown and the second one must be the one having value. So the unknown here is oxygen gas. The question says that find the volume of oxygen gas. The first one here is oxygen gas, which is O2. Find the volume of oxygen gas, or O2, that will be formed when 2.45 gram of potassium triiosochlorate 5. So what happened here? Potassium triiosochlorate 5 is having value. The two related substances, no matter how many substances you have as the reactants and the products, your attention will be drawn to just 2. And the first one will be the one with what? With value. And the second one must be the one with what? Must be the unknown, the one you are looking for. So we are saying potassium triiosochlorate 5 having value, which is 2.45. So potassium triiosochlorate 5 is the second one we are relating. So what's the next thing here? Write out the molar ratio. So we're having 2 mole of potassium triiosochlorate 5 breaking down to form 2 mole of potassium chloride and 3 moles of oxygen gas. So you're having 2 mole ratio 3 mole. So the next thing here is to check if we leave it as mole or we convert it to another measurement or another unit, I mean. So how we find out is by looking at the question. And the question on the board says that find the volume of O2. So it means that we are converting mole to what? To volume. We are converting mole to what? To volume. So to volume, now is it at STP or at RTP? from the value we have here, it will be what? It will be STP at STP. So it will be STP. So 1 mole of O2 at STP equals to 22.4 dm cube. 0.4 dm cube. Now we're having 3 mole here now. So 3 mole now be what? 22.4 times 3 moles of O2 equals to what? 22.4 times 3 times 3. So that will be what? 22.4 multiplied by 3. So we have 67.2 dm cube. So what we have here is what? 67.2 dm cube. Are we going to leave this on here as a mole, or we convert it also? Let's check. The question says that find the volume of O2 that will be formed when 2.45 grams of potassium triiosochlorate 5. So it means that here we are converting the mole to what? To mass, which is measured in gram. So we are converting the mole here to what? To gram. So 1 mole of potassium triiosochlorate 5 weighs what? That will be equals to what? Potassium is what? 39. We have 39 plus what's chlorine? 35.5 plus what is oxygen? Oxygen is what? 16. But how many oxygen do we have here? We have 3 oxygen. That will be 16 times 3. That will give us 48. So we have 48. So adding all this together, so our answer is 122.5 gram. So 1 mole of KClO₃ weighs what? 122.5 gram. But now what do we have here? We have 2 mole. So that will be this one here times 2. If 1 mole weighs this, then 2 mole will be times 2 of this. So that will be times 2. So what do we have? So our answer here is 245 gram. 245 gram. So right here we're having what? 245. Let me make it to be more closer. 245 gram. 245 gram. Now, it means that when 245 gram of KClO₃ decomposes, what is produced? 67.2 dm cube of oxygen gas is what is produced. Now, what's the question now? The question now says that find the volume of O2 that will be formed when 2.45 gram of potassium triiosochlorate 5. So when we use 245, we got what? 67.2 dm cube. What are we now going to get? What will now be formed if we now make use of 2.45 gram of potassium chlorate? we use what? 245. What did we get? We got 67.2 dm cube of oxygen. If we now use 2.45 gram of this same substance, what volume of O2 will be formed? So we have what? We have 2.45 gram, and we have X here, XD cube. Find the volume of O2. So it's unknown. What is next in here? Cross multiply. So we're having X equals to 2.45 multiplied by 67.2 divided by 245. Now our X equals to what? 2.45 divided by 67.2, we get 164.64 divided by 245. Our answer here is 0.672. So X equals to 0.672 d cube. So when we make use of 245, 67.2 dm cube of oxygen gas is produced. When we now make use of 2.45, 0.672 dm cube of oxygen gas is being formed or being produced. That is for number 1. For number 2 now, number 2 says that what mass of lead 2 triosonitrate 5 solid would be heated to obtain 11.2 dm cube of brown nitrogen 4 oxide. Lead is 204, nitrogen is 14, white oxygen is 16. So we have the chemical equation for number 2 right here on the board also. We have lead 2 triosonitrate 5 decomposed to produce lead oxide and nitrogen 4 oxide and oxygen gas. So you have lead So let's check if it is balanced. We have 2 lead here. We have 2 lead here. We are having, how many oxygen do we have? Let's check. From here, we are having 6 oxygen here because 2 times 3 is what? Is 6. 2 times 3 is 6. So we are having 6 oxygen here. So this 6 times this 2 here is what? 12. So we are having 12 oxygen here at the reacting site. We are having 12 oxygen. Now, here, how many oxygen do we have here? We are having 2 oxygen here. 2 oxygen. 2 oxygen. How many do we have here? We are having 8 oxygen here. 4 times 2 is what? 8. We are having 8 oxygen. And last we are having what? 2 oxygen. So 2 oxygen plus 8 oxygen plus 2 oxygen, that is what? 12 oxygen. 12 oxygen. So it means oxygen here is what? Is balanced. Now let's check nitrogen now. For nitrogen, we are having, from here we are having 2 nitrogen because we are having the invisible one here. So 2 times this one, we are having 2. So this 2 here multiplied by these 2 here, we're having 4 nitrogen. We're having 4 nitrogen here. So let's check here. Here also we're having 4 nitrogen also. So the equation here is balanced. It's balanced. So what's the next thing now? We find out the two relating substances. The two relating substances. Now, remember the two relating substances. One must be the unknown, the one we are looking for, and the second one must be the one with what? With value, having value. So with the question here, how are we going to find out the two? What mass of lead-2 triazonitrate 5 solid? What mass of what? So the substance here is what? Lead-2 triazonitrate 5. What mass? So the first one here is what? Lead-2 triazonitrate 5. Solid would be heated to obtain 11.2 dm³ of brown nitrogen 4 oxide. So what happened here? This particular substance here is having value. Now be nitrogen 4 oxide. Nitrogen 4 oxide. So from the equation now, we're having 2 mole and we're having 4 moles. 4 moles. 4 moles. 4 moles. So now, are we going to leave it as mole or we convert it to another unit? What's the question? What mass of lead-2 triazonitrate 5? What mass? So we're converting this one here to what? To mass. So 1 mole of lead-2 triazonitrate 5 weighs what? So what's the value of lead? Lead is what? 204. So you're having before anything, to make the work easier, just first of all open the bracket. So what we have here is the same thing as we having this 2 times 1 here, having what? 2. 2 times 3 here, we're having what? 6. So this will make our work much more easier. So lead here is what? Lead is what? 204. 204 plus, what is nitrogen? It is what? 14. You have it, but how many of nitrogen do we have there? You're having what? 2. That will be what? 14 times 2. That will give us 28. 28 plus. Now what is oxygen? Oxygen is what? 16. Oxygen is what? 16. Now, but how many oxygen do we have here? We're having what? 6 oxygen. So 16 times 6, we're having what? 96. Let's confirm. 16 times 6. 6 times 6 is what? 36. We have 6 here. We need 3. 6 times 1, 6. 6 plus 3, we're having 9. So 16 times 3 will give us what? 16 times 6 will give us what? 96. So 16 times 6 will give us 96. So 96. Now let's add it together. We're having 328. 328 gram. We're having what? 328 gram. So now 1 mole of this weighs this. But how many we have here? We're having what? 2 mole here. So that will be what? This times this one times 2. So if 1 mole weighs 328, 2 mole will weigh what? The value times 2 multiplied by 2. So we're having 328 multiplied by 2. So we're having what? 656. 656 gram. 656 gram. So 2 mole weighs 656 gram. 656 gram. Now, how about this one here? Are we going to leave it as mole or convert it also? What's the question? Would be heated to obtain 11.2 dm cube. So what happened here? We're converting nitrogen 4 oxide to a value of what? Of dm cube, and that is volume. Volume is measured in what? dm cube. So what happened here? We're not giving the, maybe it is RTP or STP, but just take note. If the question doesn't specify, maybe it is RTP or STP, okay, just make use of STP. Use STP. So now 1 mole of nitrogen 4 oxide gas at STP we occupy a volume of what? 22.4 dm cube. 1 mole of nitrogen 4 oxide gas at STP will occupy a volume of what? 22.4 dm cube. But how many moles do we have here? 4. Having 4 mole here. So 4 mole of NO2 will be equals to what? That will be what? 22.4 multiplied by what? By 4. So that will give us 89.6. 89.6 dm cube. 89.6 dm cube. So 4 mole we weigh what? Sorry, we occupy a volume of what? 89.6 dm cube. So we're having what? We're having 89.6 dm cube. Now, what's the next thing now? What mass of what? Of this. So what happened here? What mass? So we're having what? X gram. Would be heated to obtain 11.2 dm cube. 11.2 dm cube. Sorry, 11.2 dm cube. I first of all bring my value from the equation, then I now apply the question there. So what happened there? When we eat 656 gram of this, what happened? We obtain what? We obtain 89.6 dm cube. Now, what mass of this we will now make use of to obtain 11.2 dm cube? That's the question. So what's the next thing here? Cross multiply. So we're having x equals to what? 656 multiplied by 11.2 divided by what? 89.6. S equals to 82 82 what? 82 gram. 82 gram. So the make use of 82 gram, 82 gram is much more smaller than this. So when we use 656, we get a much more bigger volume. So we now make use of this small mass, we also get what? A smaller volume. That is for number 2. So that is for number 2. So please do well to hit the subscribe button, like and comment, so that this lesson might be able to reach other people also who are having issues related to this kind of calculation. Now, number 3 says that 1.78 gram of ammonia gas were decomposed completely to N2, which is nitrogen gas, and H2, which is what? Hydrogen gas. Full stop. Calculate the volume of the resulting gas measured at STP. So let's first of all write out the equation first. So we're having NH3 gas decomposed. NH3 gas decomposed. So we're having NH3 gas decomposed to produce what? To what? We're decomposed completely to what? N2 and what? H2. To N2 and H2. So what's the next thing? Balance the equation. So we have one nitrogen here. Yes, there's invisible one here. And we're having 2 nitrogen here. So what happened? Let's put 2 here. Now we're having 6 hydrogen here. We're having 2 hydrogen here. So what we'll put here to make this one to become 6 is what? Is 3. So we're having 3 here. Sorry. We're having 3. We are relating what and what in the question now. Let's find out. 1.78 gram of ammonia gas. So what happened there? Ammonia gas is what? Having value. So ammonia gas is the first one. So ammonia gas. So what's your unknown now? Calculate the volume of the resulting gas measured at STP. Calculate the volume of the resulting gas measured at what? At STP. So here now, we are not specifying the gas to calculate, but we know that these two are gaseous. These two are gaseous. So now, but to calculate for both of them. Now, for this one first, we have what? We have N2. We have N2. So from the equation, what happened? We're having 2 mole, and we're having what? Of these ammonia decomposed to produce 1 mole of what? Nitrogen gas. So are we going to leave it as mole or convert it to another unit? Let's check for ammonia. The question says that 1.78 gram of ammonia gas. So what happened here? We're converting the value of mole of ammonia to what? To mass, which is measured in what? In gram. So 1 mole of ammonia gas weighs what? So what happened here? What is nitrogen? Is what? Is 14. So you're having 14 plus what is hydrogen? Hydrogen is what? 1. How many do we have here? We're having 3 hydrogen. That was 1 times 3. 1 times 3. So you're having what? 14 plus 3, which was what? 17 gram. 17 gram. So 1 mole of ammonia gas weighs what? 17 gram. So 2 mole will now weigh what? That is 17 gram times 2. That is what? 34 gram. That is times 2. You're having what? 34 gram. So we're having what? 34 gram here. That is what? 34 gram. So are we leaving here to move as mole or converted or we convert to under units? Now what's the question now? Calculate the volume of the resulting gas. Remember, we are calculating for the two gases. Since the question doesn't specify the gas. So, but we know that both nitrogen and hydrogen are gases. So we are calculating for nitrogen gas first before hydrogen gas. So we are on nitrogen gas first. So 1 mole of nitrogen gas occupy what at STP? We occupy 22.4 dm cube at STP. So what happened here? Well, how many mole do you have here? Just 1. So times 1 is still what? 22.4 dm cube. So we're having here to be what? 22.4 dm cube. So what's the question now? From the equation now, from this equation, when we make use of 34 gram, 22.4 dm cube of nitrogen gas is produced. So from the question now, if we now make use of 1.78 gram of ammonia gas, what volume of nitrogen gas will be evolved at STP? So we are having what? 1.78 gram, and we are having what? X dm cube of nitrogen gas. So what's the next thing here? Cross multiply. So we are having x equals to 1.78 multiplied by what? 22.4 divided by 34. So our answer here is 1.17. 1.17. So we are having 1.17 dm cube of nitrogen gas being evolved. So when we make use of 1.78 gram of ammonia gas decompose, we get what? If 1.78 decompose, we get 1.17 dm cube of what? Nitrogen gas. That is for nitrogen. Now, for hydrogen now, for hydrogen now, that's how the next one. Now, for hydrogen now, here also, because here also we also be what? Here we are having mole also, and the mole we also be converted to what? To volume. Because the question says that calculate the volume of the resulting gas. So the mole here be what? Converted to what? To volume. But how many mole of hydrogen gas do we have here? We are having what? 3 moles of hydrogen gas. So it means that if 2 moles of ammonia gas decompose, what will produce? 1 mole of nitrogen gas will be produced, and 3 moles of hydrogen gas will be what? Produced. So 1 mole of hydrogen gas will occupy what? At STP will occupy
22.4 dm cube. So 3 mole will now be what? That will be 22.4 times 3. So 3 mole of hydrogen gas now be what? 22.4 multiplied by 3. Multiplied by 3. That was 67.2. So 67.2 dm cube. 67.2 dm cube. So we are passing here to what? To what? To dm cube. 7.2 dm cube. When we use 2 mole, which is 34 gram, we have what? 67.2 dm cube produced. So if we now make use of 1.78, how many volume of H2 we produce? Make use of 1.78. That is what? X dm cube. X dm cube. Let's continue. All the next thing here, cross multiply. So we have our x equals to what? 1.78 multiplied by 67.2 over 34. So we have 3.5. So 3.52, or let's say 3.5. So 3.5 dm cube. So when we make use of a bigger mass, we get a bigger volume. When we make use of a smaller mass, we will get what? A smaller volume.